Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. We're going to look at using GLCD operations over I²C protocol. So please like and subscribe to the channel. So like the video and subscribe to the channel. Those metrics are very important. So number 12, GLCD, graphical LCD devices. So I've got this board. Have I actually got it in the camera? Let's have a look. Oh, there it is. Look, that's the board I'm using, and it's got integrated circuits, etc., all across it. It's got I'm using a 40-pin device. I'm using a PDIP. You can use whatever you like. Okay. It's got LEDs. It's got clocks, etc. And I've added I'm going to add to it at the bottom I²C GLCDs. I've got quite a few to choose from. This is the circuit, and you can actually see the schematic, in the PDF that's associated with this board, and it's got a very good reference architecture for I²C, which is really important because I've got the I'm going to use RC4 and RC3 here, and to that I'm going to connect the serial data line and the serial clock line, and I'm going to connect those to the device, but I'm going to connect those through two pull-up lines. These must be pulled up, and I'll come into that again and again to reinforce that. Now, I've also, in this particular chip, got a VDDIO2 power domain, which basically means I must apply power to VDDIO2 because I am using RC3 and RC4, and they are in the VDDIO2 power domain, which is shown at the bottom here in green. So anything in green, you require that power. So no VDDIO power, no domain IO. So lots of prerequisites. You've got your GC Studio, GC Basic, you've got it all working. You can talk to the Q35. You've got some stuff attached. You've got USB TTL converter, and finally, you've got an I²C device, and I²C discovery has worked. We will look at that again. So in recap, I²C uses two data lines, data line and a clock line, SDA, SCL, and they're open collector, open drain. So they're allowed to be float upwards because they're pulled up with resistors. Typically operating at 5 or 3 volts, 3.3 volts. I'm running at 3 volts or 5 volts. I'm going to run at 3.3. There we go. So I'm going to attach a number of GLCD devices. This is a GLCD here, and I've got my pull-up resistors, and I've got my two lines, clock and data, which is called SCL and SDA respectively. So what we're going to do is use this sequence that we use for discovery, start, send an address and data, but we're going to send a lot of data and then a stop to control the GLCD. That's including initialization and all the pixel control that we need to do. And all that's done automatically via a library. Oh, let me just clear down there we go. So in our program, we are going to call the GLCD commands. We could write a function that did that, but we're also going to use a converter. And because we're going to eventually suck in a BMP via the converter, which will come into our user code. As we write GLCD functions, and as we use them, they come into the libraries, and there's about 125 different libraries, which include one for GLCD, and they're optimized in terms of how much memory it takes up. But you could write your own. These are library functions. Those libraries in turn lower level functions and capabilities like I²C. And then the compiler then pulls all that together to generate your machine specific hexadecimal file. So what we're going to do is we're going to just have a quick recap on PPS, set up the I²C, and then we'll go through a series of demonstrations in the time that we've got available. So with that, let's go out to desk cam, and here it is. That's the camera. There it is sitting there. What I'm going to do is I'm going to just go straight to GC Studio. Have I got it running? No, GC Studio. And we are just going to recap what we did with respect to, there's an update. Did you see that? There's an update coming for GC Studio. I'll just come out from there. And I'm just going to open up my folder. I've got it's in my open recents, open folder. It's in vendor boards, microchip PIC12 2010-18F. Select that folder. And in there, it will give me all the programs that we're working with. Here it is. This is where we left it. Show I²C devices to serial terminal. I'm going to pull that to the left. That is demonstration 170. I'm going to bring the terminal in, and I'm just going to check that my GLCD is operating correctly. And what I mean by that is addressable. Let's just see. It is. I've got in here my GLCD, as expected. I've got a temperature sensor and a memory device. So that's working perfectly. Now we know that's working. Let's do some work with it. Close that down. Control B to open up the files. Here we go. I'm going to use a 64 pixel by 32 pixel device. Tiny little thing. But basically, here's the code. And we've seen all of this before. We set up our chip. Option explicit, define our variables. Set up the serial. Though we won't be using it, we should. It's just there for reference. Set up the PPS. We used PPS tool in the previous video to look how we selected the ports for our communications. RC6 for transmit, RC3 and RC4. And that is shown here in my little diagram up here for port C. Good. Rest of that's the same. I then set up I²C using two defines, two constants, constants for the baud rate, and then I must tell it with a command I²C mode. It's the master. So I²C data is on C4, clock is on C4, and the baud rate is 100. You can change that to others. These are specific to this chip, which controls the buffer size. And that was exactly the same as we had in Discovery. Now, let's set up the GLCD. We're going to include the GLCD library, and that means pull it in, and those little, the open, the greater than and less than means go and get it from the library. I'm saying bring in, use this library here. It's a type 64 by 32, and that's a GLC underscore type SSD 1306 underscore 64 by 32. Big long name, but they're all in the help file. And I'm saying it's on address 78. And that exposes things to me like GLCD print, XY position string, clear screen, GLCD clear screen, print. You've got loads. You can draw boxes, you can draw circles, you can draw lines. There are many, many capabilities that you can do. So what we should do is just pop out to desk cam and see what's going on. Well, to be honest, it's going to be pretty hard for you to see this device, but I will slide it in, and I may have to stop the video. There it is. It's tiny. How tiny is it? Here's a rule. There you go. Not very big, but let's program it. So how do I do this? Control B to shut that down. That list of files. Function key F5 to program it. So I've connected. We know it's connected, and we're going to draw some boxes, some text, circles. Oh, look at that. Now I can see that perfectly. You can't. So I'm going to have to stop the video to show you. So what I've had to do is stop the video and zoom right in. Let me just reset the chip. Text. Looks slightly out of focus, I apologize, but never mind. 64 by 32, full mode. You can go and investigate the different modes, and they use different levels of memory. And I'm pulling in the ADC and putting that on the GLCD. So I must be doing some sort of string conversion there between the two. But look, you can see there's lines, circles, little boxes, etc. And there's different sizes of this type of device. And I haven't got time to show them all. Here's a larger one. Let me just zoom up. I dropped it. And the way that you enable these different ones, let me just bring that in. It's out of focus again. Let me just pause the video. What I've done is zoomed out. Look, you can see that this one is the same depth, 32 pixels, but it's longer. This is its very common brother, big sister, or whatever you want to call it. This is twice as wide, twice as deep, and that's big brother. Let me pull the camera back for you. So these are all very, very similar chips, all all use the same commands. So what we're going to do is I'm going to show you and use this one here. I'm going to hook that back up, but you can use a much larger one. This is an SSD 1309, and it works absolutely fantastic. It's much larger than it's twice the size, and it's really high resolution. It's a higher resolution device. So put that over there, stop the video, and I'm going to hook up this 78 version. So I've hooked it up. Now, what is important that you should note is that these connections there's VCC. I'm running at 3 volts. You can run at 5. As ground, SDA, SDA. They're not always in the same order. This one is in a slightly different order. So be very careful when you go pulling these things in and out that you don't use the wrong one. Let me just reset the chip. And what we're seeing here is the 64 by 32 driver in a much larger device. Doesn't quite, oh look, it looks okay within the scope, but let's do it properly. So we're going to go over to the desktop, Control J to shut the bottom window down, Control B. Control J to shut that down, good. Control B, open it up, shut down 180. Let's go direct to the parameter 200, the file 200, which is the correct 128 by 64 pixels SSD 1306. So have a look at that, and it says here the GLCD type is a 1306 and the address is 78. So this is the correct geometry for that microcontroller. It will now reprogram it, and the geometry is now correct. We can now see it's in the right position. It's in full memory mode, and then it's going to draw lines, etc. on the screen. So I'm rotating the potentiometer, and the little circle is changing. So this is Control B, the same set of commands we saw before. GLCD print strings, print constants, and then in here we saw it flash up some information, but I'm drawing a box, I'm drawing circles, I'm drawing filled circles, filled ellipses, etc. These are all part of the GLCD command set. You can also use reduced memory. I think it uses 128 bytes. And you implement something called transaction, and it enables you to use a lot less RAM on smaller chips when you haven't got enough RAM. So there's an example of a GLCD running. Let's look at what other examples we've got. Sprites written by Stan many years ago. And this will just gives you an example of sort of the games you could write on these microcontrollers and these displays. So this is a really simple example of a sprite bouncing around the screen. We can also use trigonometry, and we can use trigonometry and then use that trigonometry within the library to show some stuff. And what we're going to show is a basic voltmeter. I rotate the potentiometer and I got a very simple voltmeter, and this line is calculated by using trigonometry. So we should look at that. How do we do that? Let me shut that down. It says here, hash include less than, greater than, trig two places.h, and that will give you trigonometry to 2 decimal places, factorized. And then in here, you'll see there's sine commands, cosine commands, because they've been pulled in via that library. And so here is calculating the X and Y positions using cosine and sine, and that allows you to do two decimal point trigonometry, which is fantastic. Okay, and that's basically what it's doing, is drawing a line, overdrawing the old line, and putting a new one in. So it's very simple technique for drawing lines using trigonometry. But this is a really good use for it because you can see it operating on the screen. Let's look at 225, which is GLCD BMP. What this is doing is importing, using an import function to import a BMP as a table into GCBASIC. I'll show you how you do that once you've seen it operating. About to load a BMP, it says, and then it loads a BMP. That BMP is out in the operating system and it's pulled in via some GLCD functions. Let me shut the file list down, Control B, Control J to get rid of those two windows, and we'll look at the code. This hash include quote file specification, that's anobium full.bmp. It says include that in the program. And what the converter does, the converter will give you a program called anobium.gcb, and it will have a table called anobium full. That's the way the converter works. And then you can actually access that. And if we look in here, I can type in anobium full because it's actually on my, here it is. It created this table. And that table is quite large. Could be better formatted nowadays, I guess. There's better ways of formatting it. It's 140 points, 139 points. Must be. How many pixels is it? It's 128 by 64. So it's the full size of there, and it created that dynamically. There is a converter available, and you can write your own converters, by the way. But converters essentially take that file name that was given on the include line, executes a program that you'd like, and then pulls in the BMP as a table, and then basically you use read table. That's the table name. That's the increment, the index. It says that's the length of the picture. The next one is the width of the picture, the height of the picture, and then after that, you just basically put in things on the screen at an XY position, and just you have to work it out yourself, but you can do it. It's not that hard to do. It's really quite simple. It's just getting data with a read table and getting it in. I'm sure there's faster ways of doing this, but it's a demonstration method. Control B. That's all I wanted to show on this particular tutorial. So we're able to use I²C to I²C devices like the GLCD as representing. On this board there is a temperature sensor and EEPROM. They are fully supported through other libraries. I'm just showing you GLCD because that's the one that is sort of, you can see it with that. Back to PowerPoint. So now we've got one GLCD working. Why don't we do it with SPI? Serial Peripheral Interface. completely different interface, same GLCD command set, but we're going to slide out one of the communications protocol to SPI, and then we'll still use a GLCD because you can see it work. So that's end of part 12. Enjoy.